Okay, welcome back. In this video, we're going to look at a very useful topic in chemistry, and that's called stoichiometry. Stoichiometry. Metry is from metrics, which means measure. So we're measuring something based upon a relationship between the reactants and the products in an equation. So we need an equation. We need to know that, for instance, in an equation, if I give you magnesium metal and I burn it, I set magnesium ribbon on fire, it gives you a very, very bright light, and then a white powdery substance called magnesium oxide. So it's going to make magnesium oxide. Now magnesium oxide is MgO, oxygen in the air is O2, and magnesium is Mg. It's just magnesium metal. It's not a compound. So I need to balance this before I can get any kind of a relationship. The balanced equation would be, I've got two of these, so I need two oxygens here, which now means I have two magnesiums. It's messing up here, so I have to have two magnesiums. And now I have a balanced equation. This equation says that there are for every two atoms of magnesium, one molecule of oxygen molecule is required. So the O2 shows you that it's bound together, and so this is a molecule. One molecule of oxygen, free oxygen, is required, and two molecules of magnesium oxide will be made. So I've got a 2:1:2 relationship. So since it's a relationship, I can say 2 atoms to 1 molecule gives you 2 molecules, or I can say 2 dozen atoms plus 1 dozen molecules yields 2 dozen molecules. Or in the case of chemistry, our useful number is the mole. And a mole, 1 mole, which is abbreviated MOL, in case you need an abbreviation for a 4-letter word, 1 mole is a very large number. It is called Avogadro's number, named after Italian scientist, at 6.022 times 10 to the 23rd. So that would be 6022 and 20 zeros after it. So it's a huge number, but it's still a number. So if I can say 2 dozen of these plus 1 dozen of these yields 2 dozen of these, I could also say 2 moles of this plus 1 mole of this yields 2 moles of this. Okay, so extremely useful. We're going to use the mole in order to find out amounts. So that's where the metrics comes from. We're trying to find, if I give you a certain amount, you can tell me how much it's going to make or how much it needs to react with in order to make something. Okay, so for instance, let's start with something easier. Let's say I give you a molar amount. Let's say that I give you 2 moles of magnesium, and I'm asking you to find out how many moles of oxygen molecules I'm going to need to react with it so that it's completely reacting. So that's a little scary. You're like, I don't know, but you start with a balanced equation. As long as you're in moles, you can use this equation because this is a relationship, 2:1:2. So this is saying 2 moles of this, 1 mole of this yields 2 moles of this. Well, see, if I already have moles, I can easily find this relationship, okay? And I can do it just with a ratio, like you did in elementary school. So since I was given magnesium, I'm going to start up here with the balanced equation. Start with magnesium. I have 2 here. I'm asked for oxygen, so I'm going to go up here. I have 1 there, so I'm going to have a 2:1 relationship, 2:1 ratio. And so this is 2 moles of magnesium and 1 mole of oxygen, and it's going to be equal to, so I'm going to come back to what I was given, 2 moles of magnesium I was given. What do you think I'm going to have for oxygen? Well, 2:1 is equal to 2:1. I gave you a very easy, this was magnesium here and this is oxygen here. I gave you a very easy one. So our answer was 1. So if I give you 2, I'm going to have 1. Let me give you a different amount, okay? Let's say that you have 13.2 moles of magnesium how many moles of oxygen are you given? Okay, so, well, we're going to go back to the periodic, or go back to the balanced equation. It's 2 to 1 to 2. So I'm starting with magnesium, so I'm going to go to the balanced equation, and I'm looking for oxygen, so I'm only interested in these two, so I can skip that. 2 to 1. So I'm going to say there's 2 to 1. This is 2 moles of magnesium for every 1 mole of oxygen molecules. That's equal to, so this is what our amount is. We were asked magnesium over oxygen, so this is also going to be magnesium over oxygen. 13.2 moles of magnesium over X moles of oxygen. How much is it going to get? So my calculator says, this is a cross multiply, by the way, if you remember this. This is 2 times X is 2X equals 1 times 13.2 is 13.2, and now I'm going to divide by 2, and I'm going to see that X is going to be 13.2 divided by 2, 6.6 moles. Now what was I looking for? Oxygen. Okay, so in this case, if it's a 2 to 1 relationship, and I have 13.2 of magnesium, 1 is half of 2. I'm going to have half of 13.2 is my number of moles for oxygen. So it's simply going to be a cross multiply. 2 to 1 is 13.2 to what? When you find it out, 6.6. Now that you know the moles of oxygen. Now, if that was the question, then great, you're done. Okay. If it's not, let's start again. We have 2 mg plus, I'll put 1, but you don't need it, O2 yields 2 MgO. Okay, we'll start there again. What if I give you, instead of moles, I give you grams? Okay. So let's start over here this time. Let's say you have 3 grams of O2. How many grams of magnesium are you going to need? Okay, if you're given 3 grams, how many grams of this? Now you cannot go through the balanced equation with grams. Grams don't work because some stuff is heavy, some stuff is light. This is a metal, this is very heavy, this is a gas, this is very light. So 3 grams of oxygen is a huge amount of oxygen. 3 grams of magnesium is some magnesium, but not nearly as much as oxygen. You could fill a room with just a little bit of oxygen since it's so light. Okay, so I need to convert this to moles so that I know its relationship. Well, the way you convert to moles is you go through the molar mass found on the periodic table. So let's start with what I've given you. I've given you 3 grams of O2. And I'm going to look on the periodic table and say, now that under oxygen, I have an atomic mass of 16. Now there's 2 oxygen in this molecule. It's a double oxygen molecule. So I have to double that number. So it's 16 and 16 is 32. There's 32. Its atomic mass for this, or its molecular mass is 32. And it's 32 grams for every mole. So you look on the periodic table, you see that oxygen is 16. There has to be 2 of them here. So that's twice of it, it's 32. And I'm going to say for every mole of oxygen, there is 32 grams of oxygen. Now, I put grams on the bottom because I have grams up here. I want it to cancel. I'm trying to get to moles. So if I want to cancel grams, I have it on the top and bottom, and anything top and bottom cancels. So grams of oxygen cancel. My answer is now in moles. So I find it by taking the 3 and dividing by 32. So 3 divided by 32 equals 0.094, let's say 375, 0.094 moles, okay, of oxygen. Now I was given 3 grams. That's equal to this. These two are equal to each other. Okay, these two are equivalent. 3 grams of oxygen is equal to 0.094 moles of oxygen. You're saying the same thing. Once I have moles, I can go through the relationship in the balanced equation. So I started here with oxygen because that's what I was given. I was given 3 grams. We found out that's moles. So what's the relationship? I was asked for magnesium, so I'm ignoring this again, and it's 1 to 2. So I'm going to set up a 1 to 2 relationship. 1 to 2. So this is 1 mole of oxygen over 2 moles of magnesium equals, now we're not interested in grams anymore, we need it in moles so everything stays. So we're going to say, so oxygen's on top, magnesium's on bottom, so we're going to put oxygen on top here, 0.094 moles of oxygen over X moles of magnesium. Okay. So what do? 1 times X is X. 2 times 0.094, okay, 2 times 0.094 equals 0.188 moles. Okay, I'm trying to find moles of magnesium, so moles of magnesium. Okay, now I'm not quite done. I have moles of magnesium, okay, but I don't know what the grams of magnesium is. So I need to go back to the periodic table, and see. Let me look. Okay, I just took a field trip to the periodic table, and I found out that, so let's start with what we have. We have 0.188 moles of magnesium, and you see I have moles, so I'm going to cancel. I'm trying to get to grams, so I'm going to have 1 mole, it's always 1 mole. 1 mole of magnesium, and then here's grams of magnesium. Okay, it's 24.3 on the periodic table. And since it's just 1 magnesium, I don't have to do any arithmetic to it. 24.3 grams of magnesium in every mole. Okay, so this cancels moles, will cancel with moles, and now when I multiply, I will be in grams. So 0.188 times 24.3 gives me 4.57 grams of magnesium. And that's what I was asked to find. I gave you a certain amount of grams, and then I asked for a certain number of grams. Okay, so I went from grams to moles. Once I had moles, I went through the relationship oxygen to magnesium 1 to 2. Moles of oxygen 0.94 to I don't know. Solved it. Now I'm in moles, and now I have to go from moles through the periodic table to get to grams. So you're always going to go from grams of reactant or grams of whatever you have, whatever you were given, into moles. We'll call it the reactant. Okay, and then from moles of reactant into moles of product. Remember, or the other one, whatever you're looking for, because remember, you're just looking for 2 out of the balanced equation. There might be 10 different things in the balanced equation. You only are isolating 2 of them. Start with grams, you go to moles, then you go to moles of the product, and then you're going to grams of the product. So how did we do it? If we were in moles, remember, you can go through the balanced equation. Balanced equation. If you were in grams, you had to go through the molar mass. And the molar mass, remember, was how much the molecule weighs. So every single atom inside that molecule has a weight that you can look up on the periodic table. Make sure you multiply by the number of each of those atoms. And then, so this is molar mass from the periodic table, and you can go from grams to moles. And then when you're in moles, you do the very same thing. You're going through the molar mass again, and the molar mass will give you it'll either give you moles if you have grams, or it'll give you grams if you have moles. So I hope this helps you. Watch it as many times as you need to practice, and I'll see you in class.